Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi everybody, welcome to another episode of Lost in Math. I'm Mr. Wheeler, and today we're talking about how to solve quadratic equations by using square roots. So if you recall, we have 5 methods for solving quadratic equations: graphing, factoring, and today we're learning about square roots, and then 2 others we'll get to later. If we're using square roots, our quadratic equation has to be written in a very specific way. If you remember standard form of a quadratic equation, ax squared plus bx plus c equals 0, we can only use this method if b equals 0. In other words, if there isn't an x term. If there is an x term, I cannot use this method, but if there is no x term because b equals 0, then this method is really good because it's pretty fast and kind of easy. So if we're missing a b, square roots is the method we want to use. So if we're solving by square roots, not only do we not want a b, but we also want it to be written like this before we get started. X squared equals a, where a is some number. So you want x squared by itself equaling a number. And then we can use the square root method. So let's look at this example, x squared equals 16, to help us figure it out. It's a lot like solving an equation. It is solving an equation. To do that, remember we use inverse operations. So to get rid of addition, we use the inverse of addition, subtraction. To get rid of multiplication, we use the inverse of multiplication, division. On this problem, I'm solving for x, so I want to get rid of that squared. The inverse of squaring a number is square rooting a number. So the square root of x squared is x. X is by itself. That's what I'm solving for. But whenever you're solving an equation, you do something to one side, you have to also do it to the other side of your equal sign to keep the equation balanced. So if I square rooted my x squared, I also have to square root my 16. So x will equal the square root of 16. You're very tempted, I'm sure, to say 4. But when we square root a positive real number, we get out 2 answers. 4 is one of them. But we also get out the negative root. So negative 4 is another answer to this problem. The reason being, our original problem was x squared equals 16. 4 squared is 16, but negative 4 squared is also 16. Negative 4 times negative 4 is positive 16. So when we square root a positive number, we get out 2 solutions, one positive root and one negative root. So keeping that in mind, let's try these examples on our notes. They're already written in the form x squared equals a, so we don't have to do anything, just square root both sides and find your answers. So take a moment and try and do those. B, x squared equals 81. We take the square root of both sides. So x equals 9 or negative 9. We can write it x equals plus or minus 9. That means positive 9 or negative 9. Or if you want to write it out, x equals 9 or negative 9. Either way is fine. On C, x squared equals 13. When we take the square root of both sides on this problem, 13 is not a perfect square. It does have a square root. It's some long, awful decimal that goes on forever. So on problems like this, we can just write it as x equals the positive or negative square root of 13, written like that. Or if you wanted, you could say x equals the square root of 13 or the negative square root of 13. So that's how you do problems like that. D, x squared equals negative 36. Take the square root of both sides. We cannot take the square root of a negative number. There are no real solutions when we take the square root of a negative number. It's impossible using real numbers to multiply a number by itself and get out a negative number. A negative times a negative is a positive times a positive is a positive, so we can't take the square root of negative numbers. So when we have a problem like this, our solution will be no real solutions. It's like when we were graphing, our parabola would not cross the x-axis. There are no zeros. There are no solutions to this quadratic equation. On E, x squared equals 0. So we take the square root of both sides. So x equals 0. There is no negative 0, so it's just one answer, x equals 0. On all those problems, they were already written in the form we like. X squared equals a number, x squared equals a, and then all you do is take the square root of both sides and get your answers. On this next problem, 4x squared minus 25 equals 0, it's not written in the form we like. So when we have problems like this, we just got to move stuff around until we get it the way we want it. X squared equals a number, and then take the root of both sides and solve. So on this example, I want to move that minus 25 over to the right-hand side of my equal sign first. So to get rid of subtraction, I use addition. So I add 25 to both sides. And when I do that, I'm left with 4x squared equals 25. I want to get x squared by itself equaling a number. So I want to get rid of that 4. The 4 is multiplying x squared, so I use division, divide by 4. That turns into a 1, so I have x squared by itself. I do it to the other side, so I get x squared equals 25 over 4. Now I have x squared by itself equaling a number, 25 fourths. So I square root both sides. Square root of x squared is just x, and that equals the square root of 25 fourths. So what times itself would get us 25 fourths? 5 over 2. You can think of it as square rooting the top and the bottom. 5 over 2 times 5 over 2 would be 25 over 4. So x equals 5 halves, or x equals negative 5 halves. Don't forget, we still get two solutions, our positive root and our negative root. So that would be a good answer for this example. On the back of our notes, we have 4 practice problems where we have to isolate x squared first before we solve. So take a moment and try and solve those problems, and then we'll go over the answers. B, x squared plus 5 equals 5. First, we want to get x squared by itself on the left-hand side of the equal sign. So I get rid of that plus 5, minus 5, minus 5. So x squared equals 0. Take the square root of both sides. So my answer is x equals 0. On C, isolate x squared first. So I get x squared equals negative 9. Take the square root of both sides. I can't take the square root of a negative number, so x equals no real solutions. There are no solutions to that problem. On D, 3x squared minus 75 equals 0. Add 75 to both sides. 3x squared equals 75. Divide both sides by 3. X squared equals 25. And take the square root of both sides. So I get my answers of x equals 5 or x equals negative 5. On E, 2x squared minus 2 equals 0. Add 2 to both sides. 2x squared equals 2. Divide both sides by 2. X squared equals 1. Take the square root of both sides. So x equals the square root of 1 is 1 or negative 1. 1 times 1 is 1. So x equals 1 or negative 1. All right, that wraps up our notes on solving quadratic equations by square roots. We can only use this method if b equals 0. So it's rare we get to use it. But if b does equal 0, it's nice, fast, and simple to do. So that's how you do that. Like the video if you enjoyed it. Don't forget to subscribe. And bye, guys. The quadratic equation, we have to have it written in a certain way. I don't like where this is going. Solve quadratics by using square roots. I really should know what I'm going to say for us. An easy calculation for us. But so x on e, square root both sides. Sorry. On the back of our notes, we have 1, 2, 3, 4. We get x squared by itself first. By itself.